Hello friends, so we'll discuss Embedded Automotive today, which is actually your program elective 5 and it will be offered in your 7th or 8th semester as per your choice. This is the connecting subjects of the specialized area of VLSI and embedded systems. So you have already studied a microcontroller as compulsory subject. Few of the students have taken advanced microcontroller and then later on they have taken about embedded real-time operating systems, but this particular subject is individual. If you have studied a microcontroller in your second year, that was a compulsory subject, you will be comfortable to go ahead with this particular subject of embedded automotive. So let's understand the credit system of it. So as this is a 2-credit course, we will be having 2 lectures per week, or maybe to cover the good contents of it, it may vary according to the academic planning. But you will be having an internal evaluation of 20 marks. You know, it's IE1 and IE2 of 10 marks. That is continuous internal evaluation of 10 marks and 10 marks as per the syllabus distributions. Then we will be having a MTE, and at the end of the semester you will be having a ET of 50 marks. Overall, the subject will be of 100 marks. The structures remains the same as for all the program elective 5. Now let's start understanding that why I need to choose this particular course. So as you know, we are studying in PCCOE. It's located in automotive hubs. Lots of automotive industries are around us, and most of the placements, core placements, that belongs to this automotive industries. The companies like KPIT, Tata Motors, Minda, Model Motions offers good salaries and good opportunities in the field of the KPI. Many more companies are visiting to PCCOE in the area of the automotive, and this subject will be definitely help you out to grab your opportunity in the automotive sectors. So this course is designed with the objective of with few objectives, such as to introduce various applications of electronic systems and ECU in automotive sectors, to explore principles and applications of sensors and actuators in automotive electronic systems, and to discuss the various control systems adopted in automotive systems. Okay, basically you people are taking a part into various competitions like SAE, BAHA. You are designing various e-vehicle, autonomous vehicles. So in that case also this particular subject will be very helpful. You have studied sensors and actuators as one of the subject in your second year, so this will be in line with that, but specifically the sensors and actuators studied here are related to the automotives. Okay, so this particular subject will help you to understand all the concepts related to the automotive industries in terms of electronics or in terms of embedded. Okay, so we are required to have a prior knowledge of microcontrollers, sensors and automation, embedded C and a MATLAB. Okay, course outcome is at the end of the course the student will be able to understand the automotive components, subsystems, basic electronic controls in today's automotive industries. They could able to select appropriate automotive sensors and actuators that can be used in electronic control units, integrate various communication protocols for automotive such as CAN and FlexRace, design the safety systems in automotive applications using embedded platforms. So these are 4 course outcomes you will able to achieve after completion of this particular course, which is of 4 unit because of the 2 credits. Okay, so let's start with understanding what are the content of the syllabus. So unit 1 is about automotive systems overview, where you would like to understand what is the technology adopted in automotive, what are the present trends that you have in automobile. Okay, but it will emphasize onto the electronics and software required. Overview of the typical automotive subsystem components, body, chassis, powertrain. These are the major things where electronics is to use, embedded is to use. We will be having a specific sensors and actuators related to automotive in unit 2. So basic sensor arrangement, type of sensors such as oxygen sensors, crank angle position sensors, fuel metering sensors, vehicle speed sensors, flow sensors, some temperature, EGOs, airflow sensors and throttle position sensors, and some solenoid valves and stepper motors and relays as actuators that are being used in an automotive, maybe e-vehicle, maybe autonomous vehicle, maybe your recent trends in normal vehicles. Okay, so these all things you could able to understand in this particular unit. Unit 3 will help us understand what are the communication protocol used in automotive industries. So you may use a serial protocol, you may use parallel, you may use synchronous, you may use asynchronous. Whereas the serial communication, if you look forward, we will be having I2C, CAN and USB as the content of your syllabus. Whereas in parallel, we will be looking forward for ISA and PCI. Automotive network, that specifically for automotive, that will be CAN and FlexRace. These two will be studied in more detail in this particular embedded communication unit, which is of 8 hours. Okay. Next, the last unit that you have is about the active and passive safety system, which is very much important, and this is mostly adopted in various vehicles and various what we can say, the companies do work onto this particular area. So here we will be having content says body electronics. It will be including various things like remote keyless entry, immobilizer. Then we'll go for electronic instrument clusters and dashboard electronics, and then we'll go for embedded design for anti-lock braking system, airbags and computer vision based ADAS, introduction to your ADAS. This will complete your syllabus, giving you overview of embedded automotive, and it will be really helpful for you to go ahead with the particular what we can say embedded automotive application. So I'm looking forward for your choice. Thank you.